Imagine looking up at the starry sky and thinking that everything you see is just the surface of a much darker mystery. Behind the calm glow of the stars, there are forces so powerful that they could consume entire galaxies without leaving a trace. And the scariest thing, these monsters are there now, lurking, completely invisible to us. For centuries, astronomers believed that they had already unlocked many of the secrets of the universe. However, they were only looking at what is visible: stars, planets, and galaxies. Everything we could see seemed to make sense, but what we discovered was that the cosmos was deceiving us. Behind this tranquil facade, there are entities so strange that they defy our understanding. We're not talking about aliens or science fiction, but something real, proven, and infinitely more terrifying: the Quasars, the most powerful engines in the known universe. What are they? In the 1930s, scientists began to build radio telescopes, which are instruments that capture signals invisible to the naked eye, coming from space. It was a revolutionary moment. Among the first signals detected were radio waves coming from unexpected places in the sky. At first, it was thought that they were just unusual stars or perhaps nebulae, nothing alarming. But as technology advanced, these signs revealed something stranger. They didn't come from normal stars nor from ordinary galaxies. They were distant, much more distant than anything ever observed. Still, they shone as if they were gigantic cosmic beacons. That didn't make sense. How could something so remote be so brilliant? Scientists were perplexed. Some believed there were errors in the measurements. Others thought these radio sources might be particularly eccentric stars. But no hypothesis seemed to explain the real mystery. After all, what could produce so much energy? In 1963, astronomer Martin Schmidt, using an optical telescope, identified one of these mysterious objects, 3C273. He was like nothing we had ever seen. Located more than 2 billion light-years from Earth, it was absurdly distant, but still shined brighter than thousands of galaxies combined. That's when the term quasar appeared, an abbreviation for quasi-stellar radio source. Still, the mystery was far from solved. What powered these objects? Where did so much energy come from? Quasars challenged the physics we knew, forcing scientists to rewrite the rules. To get an idea of the power of these entities, imagine a star like our sun. Now multiply its energy by millions. That's the brightness of a single quasar. And the scariest thing, he's not a star. It is something much more destructive. Quasars have been found to be powered by supermassive black holes at the centers of distant galaxies. Yes, black holes, those same objects that, by definition, swallow everything around them, including light. But quasars are different. Instead of being completely dark, as we usually imagine black holes, they become incredibly bright when they start consuming matter. When gas, dust, and even stars are sucked into a black hole's gravity, they form a disk around it, known as an accretion disk. This disk heats up to unimaginable temperatures, releasing absurd amounts of energy. It is as if the black hole was feasting, but the process of devouring it was so violent that it emits radiation capable of traversing billions of light-years. But here's the crucial point. An active quasar isn't just a distant, harmless sight. It is a destructive force, spreading charged particles and deadly radiation wherever it goes. If one of these monsters were anywhere near our galaxy, life as we know it would be impossible. Quasars remind us of something uncomfortable. The universe is not a calm, welcoming place. He is violent, unpredictable, and full of forces that can easily erase the existence of an entire planet without warning. Even more disturbing is the idea that these quasars, which we now see as relics of the early universe, could return. The Milky Way, our galaxy, is relatively quiet right now. But in the past, our central black hole, Sagittarius A, is thought to have been as active as the quasars we observe. He just entered a state of dormancy, and one day he may awaken again. Imagine this, a force capable of shining brighter than 100 billion stars, exploding from the center of our galaxy. What would cause this? Perhaps a collision with another galaxy, like the one predicted between the Milky Way and Andromeda in 5 billion years. When that happens, Sagittarius A could become a quasar again, radiating enough energy to turn the night sky into an apocalyptic spectacle. And now the burning question: if quasars are so powerful, so voracious, what makes them capable of surviving for billions of years without becoming extinct? At the heart of this mystery is the delicate balance between chaos and order, destruction and creation, and that's what we'll explore in the next part. Around the 1930s, while humanity was still trying to understand its place in the universe, a young engineer named Karl Jansky was solving a very earthly problem: how to reduce noise in radio communications. Jansky didn't know it, but his solution would open the door to a new way of exploring the cosmos. While picking up radio signals coming from space, he noticed a peculiar noise that seemed to repeat itself in regular cycles. After much study, he realized that the source of this mysterious sound was the Milky Way itself. This may seem like a small detail, but it was the beginning of a revolution. Until then, our understanding of the universe depended exclusively on visible light, that is, on what the eyes could see. But now, with radio astronomy, we were listening to the universe. And what he said was surprising. As more radio telescopes emerged, scientists began to detect radio dots scattered across the sky. Many were identified as known phenomena, such as pulsars or nebulae, but there was a specific group of fonts that just didn't make sense. They were small, compact, and emitted absurd amounts of energy. Astronomers were intrigued. What were these objects? Were they stars? They didn't make sense. Were they galaxies? Neither. These points seemed to be very, very far away, so far away that their energy was incomprehensible. For years, science ignored these emissions, considering them errors or anomalies. Until in 1963, everything changed. That's when Martin Schmidt, a Dutch astronomer, was examining the light spectrums of one of these mysterious objects, 3C273. He found something striking. The pattern of light emissions indicated that the object was moving away from Earth at an extreme speed, and that meant only one thing: 3C273 was billions of light years away. Now take a moment to imagine this. An object as small as a point of light, but shining with the energy of 100 entire galaxies. It's like looking at a firefly and discovering that it is thousands of kilometers away, and yet it shines brighter than an entire city. Now you may be thinking, this is all amazing, but what does it have to do with me? Well, more than you might think. Just as quasars show us that the universe is not as calm as it seems, our own lives also hide storms behind seemingly tranquil surfaces. Think about how we deal with invisible challenges. Sometimes you may be dealing with something internal, a worry, a fear, or a dream that no one else can see. Just like quasars, there is a force within you that, when triggered, can illuminate everything around you. But this force, as in the case of quasars, also comes with chaos. Quasars teach us that even in the most extreme chaos there can be beauty. They remind us that even in difficult times we can shine in unexpected ways, lighting the way for others and leaving a legacy that spans time. Black holes are, in themselves, one of the most fascinating concepts in science. These are regions of space where gravity is so intense that nothing, not even light, can escape. They seem like the epitome of cosmic silence, a total absence of everything. But in supermassive black holes, what we have isn't just a void, it's the beating heart of galaxies. These cosmic giants weigh millions, sometimes billions of times the mass of our sun. They are not just big black holes, they are entities that defy logic. How can something so massive exist at the center of a galaxy without everything around it being immediately destroyed? It is in this balance between destruction and creation that the true mystery lies. Supermassive black holes, when active, become the engines behind quasars. But how exactly do they achieve this? The secret is in the matter around you. When stars, gas, and dust are attracted to the black hole, they form what is called an accretion disk. Imagine a whirlpool where everything is pulled towards the center, spinning at absurdly high speeds. In this process, the material heats up to temperatures of millions of degrees, emitting an unimaginable amount of energy. It is as if the very chaos of the universe is being transformed into light. But here's something that defies common sense. The black hole itself doesn't glow. All the light we see comes from the material being torn apart in its deadly orbit. A spectacle that, ironically, can only happen before matter crosses the point of no return, the event horizon. The Milky Way has its own supermassive black hole called Sagittarius A. It currently lies dormant, a quiet presence at the heart of the galaxy. But he wasn't always like this. Evidence suggests that millions of years ago, Sagittarius A went through a phase of intense activity, emitting jets of energy that altered the galactic environment. What if this happens again? What would awaken this giant? One of the most likely scenarios is a galactic merger. And, as you may already know, the Milky Way is on a collision course with Andromeda, our neighboring galaxy. In about 5 billion years, the two galaxies will merge. When this happens, gravitational forces will push enormous amounts of matter towards the center of the new galaxy. Sagittarius A and Andromeda's black hole will meet, and the result will be catastrophic. What was once a peaceful night sky can turn into a spectacle of radiation and destruction. We would be facing a new era of cosmic chaos, where the strength of quasars would return to remind us of the relentless power of the universe. What else do these supermassive black holes still have to reveal to us? We are just scratching the surface of its complexity, and the answers may be hidden in the heart of every galaxy we look at. If supermassive black holes are the hearts of galaxies, accretion disks are the boiling blood that pulses around them. This disk, a thin and turbulent spiral of gas, dust, and stellar fragments, is what transforms a black hole from a simple consumer of matter into a cosmic beacon capable of outshining entire galaxies. It is here, on this border between the visible and the invisible, that the universe shows its most extreme face. To understand what happens in the accretion disk, imagine a storm of cosmic proportions. Matter is attracted to the black hole, but instead of being swallowed immediately, it accumulates in a fierce whirlpool. Intense gravity causes this matter to rotate at speeds close to that of light, creating friction so extreme that the material heats up to millions of degrees. It's like a cosmic oven, where even the toughest elements are transformed into superheated plasma. Here's what makes accretion disks so fascinating. They're incredibly efficient. For every piece of matter that falls toward the black hole, about 10% of its mass is converted directly into energy. It may not seem like much, but for comparison, the nuclear reactions that power stars like our Sun convert just 0.7% of the mass into energy. In other words, the accretion disk is almost 15 times more efficient than the core of a star itself. Now think about this. A single teaspoon of matter spinning in an accretion disk could release more energy than 1,000 atomic bombs. Multiply that by millions or billions of tons of gas continually being sucked in, and you begin to understand why quasars shine so brightly. However, the beauty of the accretion disk hides incessant chaos. As the material rotates, it does not follow a smooth trajectory. Constant turbulence causes pieces of matter to collide, heat up even more, and emit radiation at all wavelengths, from infrared to X-rays. And then the paradox arises. The more material is attracted, the brighter the disk shines. But it is also this same brightness that can interrupt the process. The radiation emitted by accretion disks is so intense that it can repel the surrounding gas, creating a kind of shield that prevents more matter from getting closer. This creates a tenuous balance between feeding and resting, where the black hole alternates between periods of intense activity and relative dormancy. You may have never seen an accretion disk with your own eyes, but its presence has been detected in some of the most fascinating galaxies we've observed. A famous example is Quasar 3C273, the first to be identified. This cosmic monster, located more than 2 billion light-years away, shines with an intensity 4 trillion times greater than the Sun. And all this light comes from an accretion disk the size of our solar system. Another example is Sagittarius A, the black hole at the center of the Milky Way. Although it is currently in a dormant phase, signs have already been detected that it has an accretion disk around it. In 2019, we observed a sudden increase in Sagittarius A's brightness, suggesting that it may have consumed a significant amount of matter in a short period. These events are like cosmic earthquakes, rare, unpredictable, and absolutely devastating. But the accretion disk is not the only spectacle. As matter accumulates and rotates, it also generates intense magnetic fields. These fields function as natural accelerators, funneling particles out of the black hole at speeds close to that of light. The resulting relativistic jets can span millions of light-years, traversing entire galaxies and affecting distant regions of space. It is as if the black hole is shouting its presence to the universe, announcing its insatiable hunger and destructive power. These jets are so powerful that they can heat the surrounding interstellar gas, preventing new stars from forming. On even larger scales, they can influence the evolution of entire galaxy clusters, spreading energy and redistributing matter. If accretion disks and relativistic jets seem like distant events disconnected from our reality, think again. Every atom in our body, every chemical element on Earth was forged in extreme processes like these. Star explosions, galactic collisions, and even the energy generated by accretion disks have contributed to shaping the universe in which we live. The iron in the blood that runs through your veins, it was created in a massive star that, when it died, may have fed an accretion disk around a black hole. It's a deep, almost poetic connection. Even in the most violent events in the cosmos, there is a seed of creation. But here's the question that remains. Why do some black holes have such bright accretion disks while others are completely silent? The answer may lie in the availability of matter around them. In the early universe, when galaxies were smaller and closer together, galactic collisions were common. These encounters dumped enormous amounts of gas and dust into the central black holes, fueling their accretion disks and igniting quasars. Today, with the universe expanding, these encounters are rarer, and that means we are living in a time of relative cosmic tranquility. But this peace will not last forever. When the Milky Way finally merges with Andromeda, chaos will be inevitable. Interstellar gas will be launched towards the center of the new galaxy, reactivating accretion disks and relativistic jets. And for the first time in billions of years, our galaxy could shine like a quasar. The universe, in all its grandeur, is a constant dance between destruction and creation. Accretion disks show us how matter can be transformed into pure energy, how chaos can give rise to light. For billions of years, quasars lit up the skies like beacons of a young and turbulent universe. Today, their light still reaches us, carrying echoes from a past so distant it defies our imagination. But are these cosmic relics really confined to the past? Or would the universe be able to revive these monsters in the not-so-distant future? Quasars are not just phenomena from a universe distant in time and space. They are reminders of how the cosmos is dynamic, chaotic, and yet deeply connected. Each discovery about these gigantic cosmic engines not only unlocks mysteries of the past, but also plants questions about our future. Today, we know that every large galaxy has a supermassive black hole at its center. We also know that these black holes have already had their glory days, feeding on matter and radiating light so intense that it could be seen from the other side of the universe. But what else are they hiding? Quasars teach us an important lesson. Everything in the universe follows cycles. They are born of chaos, galactic mergers, star collisions, gas and dust being drawn toward the cores of supermassive black holes. For millions of years, they shine as the most luminous entities in the cosmos, influencing everything around them. But then, slowly, they fade away. What remains is a silent, almost invisible black hole surrounded by a galaxy that evolves in its own way. It feels like the end, doesn't it? But the cosmos has a way of surprising us. And here's the most fascinating detail. These black holes never actually die. They are there, asleep, waiting for the right moment to awaken again. And over the eons, events like galactic mergers or infalls of enough matter can reignite a quasar's light. In other words, the universe never stops creating, destroying, and recreating. We, inhabitants of the Milky Way, live in a moment of relative cosmic tranquility. Sagittarius A, our supermassive black hole, is in a state of dormancy, but signs of its past activity are still present. Fermi bubbles, for example, huge structures of energy that extend above and below the plane of the galaxy, are scars left by ancient explosions. But what if this giant wakes up? The most likely scenario would be 5 billion years from now, when the Milky Way collides with Andromeda. This galactic merger will be an event of unimaginable proportions. The night sky as we know it will completely change. Stars will be thrust into new orbits, solar systems will be torn apart, and, at the center of the resulting new galaxy, the black holes of both galaxies will merge, reigniting a quasar of epic proportions. Imagine looking up at the sky and seeing not just stars, but a constant glow, so bright it could outshine everything around you. For inhabitants of the distant future, It would be a constant visual reminder of the destructive and creative force of the universe. Throughout this roadmap, we explore the central questions about quasars. How are they so bright? The answer lies in accretion disks, which convert matter into energy with impressive efficiency. Why do they exist? Quasars are inevitable products of the evolution of galaxies and supermassive black holes. Why are they disappearing? As the universe ages and expands, the encounters that power quasars become rarer, but the potential to reactivate them never disappears. But perhaps the greatest lesson of quasars is not in the as or in why, it's in what they represent. They show us that the universe is not static. It changes, evolves, and finds ways to surprise even the greatest thinkers. Quasars are a reminder of how small we are in the face of the immensity of the cosmos, but also how much we are part of it. Every atom that makes up our body has, in some way, been connected to extreme cosmic events like these. We are literally made of the same stuff that powers black holes. And this brings up a reflection. If the universe is capable of creating beauty out of chaos, what can we learn from it? Perhaps the challenges we face in our own lives are the personal accretion disks that transform us, shape us, and make us shine. While the universe gives us answers, it also gives us questions. What other secrets do quasars hide? Does our galaxy have an inevitable destiny? And more importantly, what will be the next mystery that astronomers will unravel? If these questions pique your curiosity, subscribe to the channel right now and join us on this journey into the unknown. Leave a comment with your favorite theory or something you'd like to explore in future videos. Thank you for joining us on this incredible exploration of the universe. Each discovery is a reminder that we are only at the beginning of our cosmic journey. And in the next video, get ready to go even deeper into the mysteries that make the universe such a fascinating place. Until then, keep your eyes on the stars and your mind open to the unknown.